Hi, my name is Akash and I have just completed my master's degree in VAT value in automotive engineering. And I have done a crash simulation in LS DYNA following the NCAP rules. So I'm going to talk about how to do crash simulation in LS DYNA. The procedures need to be followed for pre-processing, meshing, and as well as post-processing in LS DYNA. So before doing the crash simulation, we need a software to design and wrap the whole geometry, which needs to be crashed using a pole or a deformable body. Here I have chosen a pole to deform the door, side door. So I have designed the side door as well as the pole using a software known as SolidWorks 2021. It is very easy to design the whole geometry in SolidWorks, so I have chosen that. CAT is also recommended by many professors, but for the ease of use I have used the SolidWorks. And here I have designed as well as assembled every part together. And after that, I have saved the file as. So this is very important because you have to save the file as either a step file, either 203 or 214, or an IGS file. Preferably, I would say step file AP203 would be preferable because it creates least number of errors. Then gives save. So after saving the file, need to go to the, sorry, so you need to go to the LS DYNA pre-post. So I have downloaded the student's version of LS DYNA R12 version. So in this, you need to choose the import. Go to the files menu, go to import tab, then select step file because we have saved it as a step file. And then click on the file which we need and select open. Then give OK because everything is in the correct dimensions only. Then using the control and as well as the mouse, you can drag as well as tilt the diagram and check for the parts which are specifically for door and specifically for impact board. This is very essential because each of the door elements are considered to be shell because it deforms under impact load. But whereas for impact beam, sorry, impact pole, it is considered as rigid because it doesn't deform in under any load conditions. So these are the some of the conditions that are being considered for this crash simulation. So after doing all that, select individual elements, and then go to element and mesh, and then give auto measure. Auto measure is adjustable for elements which are considered to be shell elements. So here you have to select active because I've chosen only one part. Select it and then give compute. Here you can give the mesh size according to your convenience because at some point of time it may not be feasible for yourself to design and mesh it with much precision because this is a student's version. If you give it with much precision, then the results will be much more precise. Then you have to mesh each of the elements using your considered mesh size, and then each nomenclature for each of the part. And you can give any kind of name. For example, here you can rename and give any kind of name. So here I have given back cover. So I have initialized each letter and gave it as BC. So you can rename. Then for the start of the pre-processing modeling, you have to go to the keyword manager. So in the keyword manager, you will see the selected options. Here it is boundary counter. So first of all, you need to go to the first thing you need to select would be the material because the material properties would be available to you through literature survey or Basically, you can select it from anywhere. You can get it from anywhere. Properties of steel, properties of composite fibers, properties of anything that you wish to insert into this. And you have to select the kind of material model. Very, this is very important because that determines what kind of deformation it will have, what kind of properties it will have. So here for the impact pole, I have chosen the rigid material. So here I have given the pole and I have given the mass density as 7.85 into 10 to the power minus 6. Young's modulus as 210. Also the specific units should also be same throughout the simulation procedure. So I've given all these material properties, and for piecewise linear plasticity is generally used for all the door components which are made of steel, carbon steel, any kind of steel you can choose. So that's it. After that, I have also chosen the enhanced composite damage. This material model is chosen for natural fiber composites. So for natural fiber composites or glass reinforced fiber composites, you can use the MAT 5455 model. So you have to check the LS DYNA directory material model to know which kind of material requirements we need. After that, you need to go to section. So in the section, you can select which kind of body structure you need to give for each part. So for the door elements, I have chosen the shell. So for the door as well as impact beam. Impact beam is inside the door. I will show it to you. So this is the impact beam. So this is the impact beam. And for the impact beam, I have given the shell element also. So this will undergo deformation. And for solid, I have chosen only for the impact pole. You have to just give the section ID, element form 1 and AET. It's not important at all. Just give it as 0. It will be in the predetermined form only. You just need to give accept. So for each, after doing all the inputting all the input parameters, you need to give accept and click done. So you are given the section properties. Then go to the part. So in the part, you need to specify. So in this mesh, I have given the each the abbreviations. So that will be present here. BC, DS. So BC means back cover, DS means door shell. So I have given each nomenclature for each part. It doesn't matter. It's up to you which kind of nomenclature you need to give. So for the back cover, I have chosen the section ID door. Door is using shell element and click done. Similarly, I have chosen for each. For impact beam, the material ID is different. I have chosen the PIB, which is enhanced composite damage. So for that also you can give any kind of abbreviations. It's up to you only. Then for pole, I have chosen the pole which is solid section. Material is rigid, so it will not undergo any kind of deformation. And that's it. Then you have to give initial. So initial, you have to go downwards and then give velocity for rigid body. Here I am moving the pole. So I need to give a velocity. And since the pole is supposed to be moving in the positive z direction, so pole will be moving in the, sorry, negative z direction. Here it is the negative z direction. So I given the negative value of velocity. Here I am giving the velocity in meters per second. And it's supposed to be 8.33, which is almost equivalent to 29 kilometer per hour. And give accept and give done. So you given the initial value. Then slowly give the control. So here you need to give accuracy. Accuracy you give this as 1 and this as 2. It will be predeterminedly given in the directory itself. Then go to the hourglass. So this is very important. You need to give the value 0.05 anything above point 1 is not acceptable. So give anything below in between 0 and point 1 and then give accept and click done. So that's also done. And after that, contact. Contact should be determined very properly because that gives an idea how the forces are being transferred between each part, between each component. So for example, for all the parts that is coming in contact with the impact beam or coming in not in a direct way but in an indirect way, I have given the contact specifications such as automatic surface to surface. So that is very simple. You need to click on that, select. So before selecting and everything, first you need to select the by part. So equation 3, part ID. So you can simply select part ID 3, here also 3. So this is the layer segment and this is the master segment. So master segment means the one which is one where we need to record all the impact load values or the energy absorption values, etc. So select accordingly and give 1 here. Also you give master slide forces included 1. Then select whichever part you need to give the forces. So here I have given pole, P is for pole. Here S means sheet. Sheet is this thing, door sheet. Just given simple, stupid kind of abbreviations. Doesn't matter. Only thing matters is that you need to remember which kind of abbreviations you are given and why. So, and I've given for each kind of contact for each parts. So whatever comes in contact with the pole, I have given automatic surface to surface. Also certain parts inside the door, I have given surface to surface contact. After doing the pole impact, then you need to certainly define certain other kind of contacts. For example, I have given spot weld here. This is for parts that is welded together or spot welded together. So here I have welded back cover and dorsal. So I will show the back cover is this part and dorsal is this part. So this two have come separately in step file. Need to check all that kind of things and give the contact type accordingly. So I have given one more contact type, which is the tight shell edge to surface. That is between sheet and dorsal. So you all know that the door part that is riveted together is the between the sheet as well as the dorsal. So I will show the diagram. So sheet will be this and dorsal will be this. So between them I have given the riveting kind of contact and that is the tight shell edge to surface. So after defining the contact and everything, we need to give certain other kind of parameters. So here I have given material, section, part, control and contact. You can for the post-processing material properties, so I have given ASC2 option. So in this option, two things are very important for us, and it is namely MATSUM. From MATSUM only we will get the acceleration, velocity, distance, force values, etc. You get from MATSUM only. They have chosen other thing that is the RC force. RC force is the resultant internal interface forces. That is for the pole impact. So with the help of that only we can get the energy absorption value. So that's it. file by clicking here, and you can give whichever title. I have given head steel because this consists of the impact beam with whose cross-sectional shape is hexagonal and material steel property is steel. So you can give whichever title you want. Then you need to go to the entity creation. So here you need to define the boundary, and in the boundary there is known as SPC. So you have to click that and go to create, and create. For each part you need to specifically define through which all axis it can move. So for example, for the back cover, I've chosen the all the parts are supposed to be constrained except for the positive z direction. So not only z direction, sorry, for you can check like 1 1 0 0 0 0. So all the zero represents unconstrained and 1 represent constrained. So for back cover, I have chosen x and y directions as constraint, and similarly for each part I have chosen almost similar to that, except for the impact pole, where I have only given access to z direction movement. And for another, you have to make sure that the door edges are hinged upon. So on these hinges, no other kind of motion should be happening. That means it should be stuck there, such that the door impact absorption energy can be calculated very easily. So for that, we need to give constraint on each of the direction. That's mean totally constrained. Thing procedure as well as meshing inside LS DYNA. So after this, I would show the post-processing procedure followed in LS DYNA. Open and then go to LS DYNA keyword plus D3 plot. So after simulating, so I have forgot one thing. After doing all the things and save the file, you need to run the LS DYNA. So ls run will pop up, and normally according to the mesh size as well as the number of nodes, number of parts that are present inside the geometry, the mesh, it may require days, it may require for hours, etc. It all depends on the kind of geometry you're creating. Then click here, input file, you have to click here. You can click any kind of file, and then whichever file you have given the pre-processing, then give open. Here you need not change anything. All the things will be accurately pointed out by the LS run itself. Then give play button. So during the running status, do not engage in any other kind of activities in laptop. It is advisable because this kind LS Dyna takes much more RAM than any other kind of processing. So you need to give certain time for the laptop to compute all these kind of values. Pre-processing and giving the run for the LS Dyna, need to go to the file menu, open LS Dyna keyword plus D3 plot. So given the D3 plot initially itself, so check, yeah, I will open, wait, let's see, 1 minute. I will open this file. So here you can see that there is an animate button here, and if we choose correctly, if we place the geometry accordingly, you can see the animation. So this gives almost accurate depiction of whatever crash simulation you are following in real time. So this is for visual purpose only, and you can do certain post processing. So you go to FEM, go to the post processing, select the fringe component. So using that, you can define whichever kind of value you need to present in front so that you can show. So here, for each node, for each element, what kind of changes will be happening. So here the values will be present. You can take the screenshot and show it in front of the presentation. Won't miss the stresses. Everything you can choose. And then more importantly, you can choose the ASC2. So for ASC2, we have predeterminedly used the MathSum and as well as the RC4. So from MathSum, you can load. So these are the material IDs. Generally, I choose all the material IDs so that you can get an overall value for whichever quantity you're choosing. So here I am choosing certain displacement, RB displacement, and then give plot. You will get an overall graph containing all the material ID. So if you need it as a single file, a single graph, you need to give some curves and apply. You go to the operation, offer some curves, apply. So you'll get it as a single file. You can save this file in any format. So here you can give a curve file. That means it will save it as this graph only. Or if you want to plot it in Excel, you can use msoft CSV multiple x-axis. You can save it as like that. You can browse any folder and give a file name, then save, and then here also you need to press save. Otherwise, it will not save. So yeah, that's it. That's it about the displacement graph. Then you can go for velocity, acceleration, momentum, kinetic energy, whichever quantity you need to express. Then after using the math sum, if you need to go to other parameter, just click the button undo. Then click the RC4, click load, and you get all the kind of contacts. These are all the contact numbers. Generally, I use contact all the contacts. Otherwise, you can also specifically find out which kind of contact you require. You can choose the here I will choose the resultant force. You can see all the values of force for each part and for each contact as well. So here simply give some terms. Apply, you will get the sum of the forces. So this is the resultant forces versus time graph. Normally it will show resultant force versus distance graph. If you want to plot it against time graph, then you need to go to the XY plot. Add two files, that is this force versus displacement and displacement versus time. You can plot it with XY graph and then it will give example I will choose Vx and Py. Sorry, Py. Then cross x-axis and choosing Vx, y-axis and choosing Py. Got it? Here I am getting the resultant force versus displacement. So this is some kind of error, but you will get it when you do it. So displacement. So if you need energy versus displacement, you need to integrate the plot. Here there's an option known as integrate live. So you will get the energy absorption value. Highest value is 507. kilojoules. Get that? So that's all about the post processing. I wish to communicate with you. With very good practice, anyone can do this kind of simulation, and I hope you found my video presentation useful.